Hi, good afternoon. I'm Vasu Dasari from HPE. Currently working on a feature on OVS where a user can specify entire encapsulation header fields that need to be used on a tunneled packet and also specify which port to use to send the packet out of the switch. In this talk, I'll present why I needed it and what I had done to make it work, and the current state of the work. So let's get started. Currently, I'm working on SDN controller framework. The goal is to manage and control any programmable switch which can provide programmatic interfaces that the framework is looking for. On the right side, you can see there are 6 switches and all of them are connected in some fashion. They need not be in a mesh fashion as shown here. These switches are managed by controller. All the switches are told who the controller is. Once the switches are connected to the controller, it queries all the switches about their identity, physical interfaces, bridge information, etc. So controller knows exactly what the switch MAC address is and information of all the ports in the switch. By using some discovery protocols, controller can figure out the network connectivity graph as well. Then controller enables L2 and L3 functionality for the end devices by programming the switches to use some tunneling mechanism in the network fabric. So you can think of the controller as a topology manager or intelligent path computation engine or some kind of tunnel manager, intelligent tunnel manager. And everything is written in Erlang. If any Erlang engineers are in the conference, I would like to say a special hello. Currently, this framework works well with a proprietary switch. I wanted to add some programmable switches to the framework as well. So wanted to see if I can put OVS also as part of my SDN framework. Switch requirements are quite simple from the SDN controller point of view. From the controller's point of view, it needs to have a switch spawn VxLAN tunnels programmatically, which OVS can do via OVSDB. Switch needs to allow specifying the entire tunnel specification header fields and which port the tunnel packet should go out of. As you see, controller knows entire network graph and knows exactly how a tunnel is laid out in the internal fabric. For example, here there is on the right side you can see there are 4 switches S1, 2, 3, 4, and they have 2 endpoints A and B. They want to talk to each other. Say there is a VxLAN tunnel going from S1 to S4. Currently in OVS, it relies on underlying next TCP IP stack or the IP stack of the operating system where it is deployed on to determine how the VxLAN packet is going to be routed in the network, and hence the path it has to take. So if TCP stack determines that the path has to go through path number 1, then it's going to take that path. But if SDN control has different thoughts on how the packet should leave, there is no way of communicating that to the OVS. Say controller wants to use the path number 2, then controller should be able to tell OVS which port to take. In the case it is S1 to S3, and the source MAC address, destination MAC, and the VLAN ID to be used in the encapsulation header. There's no way for the controller to influence the directive. This is the problem I had, and asked for some kind of direction on how to go about solving this in the OVS Discuss mailing list. I was told that this is not possible for now, but it's a good feature to have. And here I am presenting how I have gone about solving this. On the right side, you can see there's a picture of VxLAN packet format. It has original user packet and encapsulation header, which can be subdivided into layer 2, which is a source and destination MAC address, VLAN ID, L3, which is a source and destination IP address, and tunnel information like tunnel type and tunnel identifier. Currently, to create a tunnel, OVS expects user to provide L3 and tunnel information alone. So OVS eth-src command expects tunnel type, which could be VxLAN, GNU, GRE, etc., source and destination IP address, tunnel identifiers, destination address, and tunnel identifiers could be flow, wherein that information is derived from OpenFlow rules. Layer 2 information and the egress port to take for the packet are fetched from the TCP stack. So here are the extensions which I'm proposing. I would like to add source MAC address and destination MAC address, VLAN ID, and outgoing port as the extra parameters. The tunnel creation command will be enhanced to accept these options. For a tunnel to be treated as fully specified tunnel, user has to specify the source MAC address for sure, and remaining fields can be derived via OpenFlow rules by specifying them as flow keyword. Extensions being proposed are completely optional. If the user does not specify these optional fields in its entirety, then the tunnel is going to behave exactly like what we have today. First version of the code I worked on is done in the OVS user space. Depending upon how the community receives this feature, we can add it to the kernel mode as well in the second phase. As you can see, all the extensions are layer 2 only. It does not have any bearing on the protocol that's used for encapsulation. So whatever I'm adding right now, that can be used for VxLAN, Genio, or GRE, or any encapsulation supported by OVS. So the proposed extensions would reflect in the tunnel creation command as shown here. The text in the orange is the new options being added. The command should be looking familiar. Here the user is trying to create a VxLAN tunnel whose name is VxLAN1 by specifying local IP, remote IP, tunnel ID. And syntax for adding L2 fields will look like this: destination, DST MAC, source MAC, and DL port and VLAN ID. I'm using these keywords as they are similar, as these are same ones which are used elsewhere. And in this second example, user is trying to create a VxLAN tunnel VxLAN2 by specifying source MAC address alone. And user expects to derive the rest of the fields from the OpenFlow rules. To implement, here is a simple switch configuration. It has a bridge BR0 and 2 ports, AP0 and access port, FP0 which is a fabric port. These are connecting two endpoints, A and B, A which is a IP endpoint and B which is a VxLAN endpoint with VNI ID of 1000. To enable the communication between A and B, I just had to create a tunnel and enable normal flow as shown here, and everything else should work naturally. To implement this feature, I had to make some critical changes. To OVS tunnel key attribute enum in OVS openvswitch.h, I had to add 4 new key attributes: ton DL port, ton eth source, ton eth-dst, and ton VLAN ID to identify the 4 new fields. Also added 4 new corresponding metaflow fields, 2 metaflow.h, which are in line similar to ton ID, ton source, etc. These will enable OpenFlow actions or OpenFlow match operations on the newly added fields. So here are some examples of using these new fields. The first one is a learn action. If a packet arrives on a tunnel port VxLAN1, then copy the ton DL port, source MAC and destination MAC to OVS registers. And in the second example, when a packet arrives on port AP0, then that needs to leave VxLAN2 with the eth-dst VLAN ID and override into a new value, and should have gone out of ingress port 4. Here the port 4 is the OpenFlow port number. Testing. To test this feature, I have written 3 unit tests. All these are written under system user space packet aware AT suite. First one is ping over fully specified VxLAN tunnel. Is a simple test which does the same thing as shown in a couple of slides ago. Second test is the same as the one that the VxLAN tunnel is riding on, is the same as the first one, except that the VxLAN tunnel is riding on a VLAN. Third one is a combination of tests 1 and 2 and also has a regular VxLAN tunnel. This demonstrates that all 3 flavors can coexist on a single switch. All these tests written are for VxLANs only, but they are equally valid for Genio or GRE types, although I have not written any tests explicitly using them. The entire code for this work is on the GitHub at the following link. I have a branch called FST, which is fully specified tunnels. In this repository, I'm fixing some legacy test cases. Once that is done, we'll send out a request for code review. Entire code changes span across close to like 15 files. Most of the changes will look like cookie cutters, but some in OFProto, DPIF, exploit.c, and tunnel.c need some close attention. I've been working alone on this I'm looking for someone to collaborate with to explain more of the model and walk through the code so that they can help me getting the code reviewed. Please let me know. Also, please let me know if you have any comments on the feature or have any more ideas or enhancements that can be done to make it even better. Thank you.
All right, let's thank our speaker, Vasu. I think that Vasu is here, and I see that we have one question already. And this question comes from Flavio Fernandez, who asks, or who says, using OpenFlow rules available today, we should be able to set things like the tunnel ID and MAC addresses, right? So the proposed change is mostly to avoid the need for the rules by using the OpenFlow port with a new attribute. Is that all right?
Actually, with existing code, we can set the tunnel ID, override the tunnel ID using OpenFlow rules, but you cannot override the MAC addresses. The MAC addresses, when someone tries to override MAC address, it's going to override the user packet's MAC address, not the outer packet's MAC. So the thing which added is going to override the outer header ones.
That matches my recollection of the tunneling mechanism too. So we're over time for this talk, but I want to thank you again for the talk and for your work on OVS, and we should move on